Hello students, today we are going to distinguish between ionizing and non-ionizing radiation. It is a part of Unit 1 from Radiation Application and Safety. Let us see the definition of ionizing radiation. It has enough energy to remove electron from atoms creating ions. Atom as a whole is a neutral. And if we go to the structure of atom, we can see that at the center it is a nucleus, and to that electrons are revolving around the nucleus. So any radiation which has enough energy to remove those electrons which are revolving around the nucleus, it makes the system it is the system of atom as unstable, creating it becomes an ions. So any radiation which has enough energy to remove electron from the atom creating ions are called as ionizing radiation. Whereas non-ionizing radiation, it does not have enough energy to remove electron from the atom. Energy level of ionizing radiation, it has a high energy, and under this comes X-rays and gamma rays. And non-ionizing radiation, it has low energy. Example is radio waves and visible light. Examples of ionizing radiation is X-rays, gamma rays, alpha particle, beta particles. Whereas non-ionizing radiation, under this radio waves comes, microwave, IR, visible light, and UV, some portion of UV which is getting overlapped with the other portion, but it also comes under non-ionizing radiation. Now nature of ionizing radiation is it has high frequency and short wavelength, whereas non-ionizing radiation has low frequency and long wavelength. Penetration power. Ionizing radiation has a high penetration power. It can penetrate through tissues, require dense shielding to avoid it from getting inside the tissues. Whereas non-ionizing radiation has low to moderate type of penetration power, and example is UV, blocked by skin, radio waves pass through. So this is example of non-ionizing. Other example is visible light also. We can easily block the visible light. Ionization capacity. Let us see the ionization capacity of ionizing radiation. It can ionize atom, cause DNA damage, whereas non-ionizing radiation cannot ionize atom, so hence it cannot alter DNA. Now the biological effect of these two radiation. Ionizing radiation can cause cell damage, it can cause cancer and even genetic mutation, whereas non-ionizing, it is generally less harmful. And heating effect we can see, for example microwave, it can heat, so we are making use of that microwave in cooking the food. So shielding required. In order to block this radiation, what kind of shielding is needed? For ionizing radiation, thick lead concrete is needed, whereas for non-ionizing radiation, less shielding is needed. UV can easily be blocked with the help of glass. Let us see the health risk. Ionizing radiation has higher risk of cancer, radiation sickness, etc. Whereas non-ionizing radiation, it has lower risk, but UV can cause skin damage. Even we notice sunburn also. Energy of ionizing radiation. Ionizing radiation has a high energy, typically more than 10 electron volt. It has high energy. That's why it can knock out the electron from a neutral atom. For example, X-rays, kilo electron volt, gamma rays has kilo electron volt to mega electron volt values, and alpha particle, it is having mega electron volt. Non-ionizing radiation, it is as we know, it has a low energy, typically below 10 electron volt. That's why it is not able to ionize or knock out the electron from the atom. Example, and radio wave, it's somewhere about 10 to the power minus 6 electron volt. It is having microwave, it is having 10 to the minus 3 electron volt. IR 0.1 to 1 electron volt. Visible light 1 to 3 electron volt, and UV radiation 3 to 10 electron volt. Some portion of it gets overlap with the ionizing part, that you need to remember. Full UV is not non-ionizing. Portion of UV comes under non-ionization, and whereas the other portion comes under ionizing. So we can it is very important to write some overlap with ionizing radiation. Thank you.